Hello, my name is Lee Montz. I'm with GL2M Engineering. This video is about the second chiller plant that I ever designed way back in 1990. Obviously you can see it was not done in CAD. We didn't have CAD back then, or at least we didn't at the firm I was working for. The purpose of this video is to show you essentially how far back my personal chiller design experience goes, and to discuss a few important issues about good chiller plant design. This additionally is a thermal storage system, and it's pretty cool. These tanks right here are about, I think they're about 10 feet in diameter and about 10 feet tall. They have coils inside them made out of plastic. What we're doing with this system is you basically make ice at night with off-peak cheap electricity, and then you melt the ice during the day when the grid is being taxed. It's not meant for loads that are steady, but it's an interesting concept in that it allows the utility company to not have to build new infrastructure to support the peak load, because that's their problem. They have to build generation plants and wires to support the worst case hottest day of the year in their area. And if you can shift load then to off-peak hours, then they don't have to build infrastructure. And so some areas they offer rebates for people who are capable of putting in these types of systems. This particular plant got a rebate of around $60,000 back in 1990. I remember my boss was thrilled because it was the first time the facility department ever handed money back to the company instead of the other way around. This design was done on mylar in ink. Of course, that's old school. We don't do it that way anymore, but let me show you some things about this plant. This is a water-cooled chiller plant. Here's the cooling tower. This is Minneapolis, so it gets very cold. So it has an indoor sump down below because otherwise you have to put a heater in this sump, and that's expensive, it's wasteful. This is the pump skid. It's got 4 Bell and Gossett pumps on it. These devices here are suction diffusers that cleans up the water entering the pump. It allows me to basically build a smaller area for the pumps. There's a few elements in just about every pump design. You'll see these are flex connectors here. This is a triple duty valve. Triple duty valve on the discharge of a pump is an essential ingredient. It serves 3 purposes, as the name implies. It serves as a check valve, a balancing valve, and a stop valve. And so if a pump is not needed, it prevents water from flowing backwards into that pump. And that's essential because if you start that pump while it is flowing backwards, you'll likely break the pump. These are air vents, obviously. You can see those everywhere. This is your differential pressure sensor at a typical cooling coil, and it is driving the variable frequency drive, which is speeding or slowing up the pump. And here's an expansion tank. This is another critical ingredient with an air separator. Believe it or not, there are lots of chiller plants that are missing these. It's not a good design. In fact, it's dangerous. Without an air separator and an expansion tank, number one, it's hard for pumps to pump a mixture of water and air, so they're not very efficient if you don't have all the air out of the system. Number two, critically, if the chiller plant goes down and the water temperature inside the pipe grows by even 20 degrees, water, as you know, is not compressible, and so pressures can climb catastrophically quickly. And what usually happens is a valve will fail and the system will start flooding the building, and obviously the chiller plant goes down. So these are critical things that you have to have in any good chiller plant. That's it. Thank you very much for your time on this. There's other videos on much more recent chiller plant designs, but this one is one of the early ones. Thank you. Again, this is Lee Montz with GL2M Engineering.